In this video, we will look at some harder U-substitution examples. So I'm beginning with example 6. This is continuing my numbering of examples from the last video. In the last video, we got up to example 5 for the section. Okay, so for this question, let's see how we might begin. So maybe we try a U-substitution, and maybe, I don't think it's going to be perfect, because if I let U be something like 1 plus x squared, I don't quite see the derivative of that exactly in the numerator. I see x to the 5. The power is too big. But let's see what happens if we just try it. So if I do the derivative, and I write du, the derivative on the other side would be 2x. Got to make sure I write that dx. And then let's isolate that dx. We'd get du over 2x equals dx. And now let's try to substitute. So we'll get the integral of x to the 5 over square root of u times dx. And dx is du over 2x. And there's a little bit of cancellation that happens. We get the integral, and so one of the x's here cancels with an x here, and I'll get x to the 4 on top. So we end up with x to the 4 over root u du. So the question is, if I get to a point like this, I still have that x in here. Can we make this work and be helpful? Be actually something that U-sub is helpful to us in. Can we make this work and be helpful? So I want you to pause the video, because this is the heart of the question. What can we do now? Pause the video for 1 minute and see if you can find a way to make this be helpful, to get this completely in terms of U. 4, 3, 2, 1, pause the video. Pause the video for 1 minute to try this and think about what we might be able to do. Alright, so hopefully you've done that. Hopefully you paused that video for a minute to think about that. So the answer is yes, we can. We can make this work and be helpful to us. We just need to use our substitution again. Our substitution was u equals 1 plus x squared. We just need to use that again. So I need to plug in for x to the 4. Let's isolate the x. So we would get u minus 1 is equal to x squared. So if I want to get x to the 4th, I just square both sides. So u minus 1 squared would be equal to x squared squared. And with a power to a power like this, we multiply the powers. And we get x to the 4th. So now we know what x to the 4th is in terms of u. Let's substitute that in. So we are going to take this and we are going to substitute. Okay, so x to the 4th is u minus 1 squared over root u du, and we have it completely in terms of u. And this is something that we know, hopefully, how to do. So at this point, pause the video for about 2 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it for 2 minutes and see if you can finish this one off. Alright, so hopefully you did that. Hopefully you paused the video and tried this for about 2 minutes. That may not have been enough time to finish the question, but that's totally okay. I mostly care about, can you think about how to begin, what the key steps would be. Okay, so I'm doing this integral. I can multiply out the numerator. U minus 1 squared is u minus 1 times u minus 1. U minus 1 times u minus 1, I FOIL that out, and I would get u squared minus 2u plus 1, all over that square root of u, all over square root of u du. Then I can split this up into 3 fractions. This is going to be the integral of u squared over root u minus 2u over, and actually it's going to be more helpful if I rewrite the square root u as u to the 1/2. So u to the 1/2, let's do that. Same thing here, u to the 1/2. And then with the last one, I get plus 1 over u to the 1/2 du. because now I can simplify each fraction. U squared over u to the 1/2, that's an exponent property I need to use. I subtract the exponents. This is u to the 3/2. Next term would be minus 2 u to the 1/2. And the final term would be plus u to the negative 1/2 when I bring the term up to the numerator, du. Okay, so we've simplified them. Now we are ready. You know what? I think there's one thing I was forgetting. After I did my simplification, I think I forgot to write that 2 still. Yeah, I didn't carry that 2 over. So this 2 that was here, let's pull that out in front. I should have had 1/2. Sorry about that, my apologies. So let's fix that in these subsequent steps. I should have that 1/2 in front of all of these. So let's put that 1/2 in front. Okay, so equals 1/2 times the integral. Same thing here, 1/2 times the integral. Same thing here, and same thing there. Oops, sorry about that. So I forgot that 1/2 that was out in front. Okay, so let's do the antiderivative now. We have that 1/2 in front. And all of these are just some reverse power rule. If I do that for the first term, I get u to the 5/2. I divide by 5/2, which is the same thing as multiplying by the reciprocal, 2/5. With the next term, the minus 2 stays there, because that's a constant multiplying my function. And then from reverse power rule, I'm going to get u to the 3/2 when I add 1 to the power. Divide by 3/2, but that's the same thing as multiplying by 2/3, the reciprocal. With the next term, I would get u to the 1/2 when I add 1 to the power. Divide by 1/2, which is the same thing as multiplying by 2, the reciprocal. And then I have to put a plus c, because this is a general antiderivative. That's what the indefinite integral means. Okay, so there's 2 things I can do now. I can distribute the 1/2 into these 3 terms to simplify it a bit. And I also need to substitute back in for the u's. So if I distribute in the 1/2, I would get 1/5 times this first term, so something to the 5/2. And what was u? Well, u was 1 plus x squared. With the next term, the 1/2 will cancel one of these 2's, and I'll be left with a minus 2/3 times something to the 3/2, and it's 1 plus x squared to the 3/2. With the last term, the 1/2 cancels the 2, and I just get 1 plus x squared to the 1/2 plus c. So very long looking answer here, but nonetheless, that is what it is. So the key here was that u sub initially, when I did it, gave me this integral here. I wasn't able to completely eliminate the x's, but I could use my substitution one more time to convert it completely in terms of u, so that I ended up with an integral that was easy enough to evaluate. So sometimes that'll happen when I do u sub questions. Let's look at one more example in this video. Okay, so let's say I wanted to do the integral of e to the 1 plus t minus e to the t dt. So first what I want you to do is pause the video for 2 minutes, try a u sub, and see if it ends up working. Or it doesn't necessarily have to be a u sub, just try something for about 2 minutes and see if it is helpful. 4, 3, 2, 1, pause the video. Pause it for 2 minutes and see if that ends up working. One thing I want to mention about this is this 1 plus t minus e to the t, that whole thing is in the exponent of this e. Alright, so hopefully you've done this. Hopefully you've paused the video for 2 minutes just to try it. Probably not enough time to finish the question. So I'm going to do this in 2 attempts. So attempt 1 isn't going to quite work, but it's important. I want to do it because I think it illustrates something important. So we've seen before sometimes when we have e to some power, sometimes letting u be that power is helpful. What if I let u be 1 plus t minus e to the t? Then the derivative du would be, derivative of 1 is 0. Derivative of t is 1. And then minus, the derivative of e to the t is just e to the t. But I have to make sure that I write that dt on this side. And it's this whole thing times that dt. So I have to put a parentheses around it. And now let's isolate the dt. So we get du over 1 minus e to the t equals dt. And now let's substitute. So we get the integral of e to the u times dt, and dt is du over 1 minus e to the t. So I have some of the t's gone, but I still have one t. I have this e to the t in the denominator. So if I think about our substitution here, I actually, with this e to the t, I can't eliminate the t using our substitution one more time like we did in that last problem, using u equals 1 plus t minus e to the t. Why? Why does that not work? Well, if I try to get e to the t by itself, e to the t would be 1 plus t minus u if I just rearrange some of the terms. But I still have a t over here, and that's no good. I don't want to have t's in the thing that I end up plugging in. So I'm going to put a sad face here. So this doesn't work. So doing this u substitution was not helpful, even if I tried to use my substitution one more time to plug in for those straggler t's that were remaining. So let's try this another way. So in this question, I have to get a little bit creative. I have to remember my exponent properties. Seeing the fact that we're subtracting two things in the exponent, that reminds me of something that we did in the very last example, which is if you have like e to a power divided by e to a power, that's e to the a minus b. So let's take our subtraction in the power and rewrite it as a fraction like this. Let's rewrite it as e to the 1 plus t over e to the t dt. Okay, and then I can use an exponent property on e to the 1 plus t as well. The addition in the power means it came from a multiplication. That's e to the 1 times e to the t. And then all over e to the t dt. Okay, so we're making some progress. Okay, so this e to the 1 is a constant that's multiplying my function. I can pull that to the front and get e integral e to the t over e to the t dt. Okay, so at this point, pause that video one more time for about 1 to 1.5 minutes and see if you can find something that will end up working for this integral. 4, 3, 2, 1, pause the video. Pause it for about a minute, minute and a half to try this question from here. Okay, so hopefully you've done that. One thing I want to point out again is this came from exponent properties. We use some exponent properties here. Okay, so let's talk about it now. We can do this integral now with some u sub. I can let u be e to the t now. Then du, the derivative, would be e to the t. And I gotta make sure I write that dt. It's not right unless I write that dt over there. Let's substitute in. So we end up with that e in front, integral, and I notice this e to the t dt, well, that is just du. So that's pretty nice. So we have that du there on top, and the denominator is e to the t, but e to the t was u. So this is e to the u. So nice. Okay, this is a whole lot simpler now. I just had to do some exponent properties and a u sub, but a lot simpler. So we end up with the e in front, just that constant. Integral, having that e to the u on the bottom, I can bring it up to the top, but make the exponent negative. So I get e to the negative u du. And that's something I know how to do the antiderivative of. I know how to do the antiderivative of e to the negative u. Pause the video for 30 seconds if you haven't gotten to this point already, and try that antiderivative. You might have to do a little bit of guess and check. 4, 3, 2, 1. Pause that video. Pause it for 30 seconds to try this. Alright, so hopefully you did that. But that antiderivative is e to the negative u with a negative in front. I need that negative in front because the derivative of e to the negative u involves chain rule, I get e to the power, but then I have to multiply by the derivative of the power. That's chain rule, which is a -1. Okay, so I need to put that negative in front of this thing to cancel out that -1 that would pop out from taking the derivative. Okay, it's an indefinite integral, so I have to put a plus c. Okay, so I can use exponent properties to simplify this. It's a negative, let me write it in front. And this is technically e to the 1 here. So when I multiply these terms, I add the powers. I'll get e to the -u plus 1 plus c. And now let's substitute back for what u was. So we'll get negative e to the -u, which is negative e to the t, plus 1, and then plus c. And that's my answer. So we have now finished our final goal for this section, which is we did some harder U-substitution examples.